Video 4, we are going to introduce a new abbreviation. Just when you thought side, 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 side angle, side angle, side angle, 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 side, and HL wasn't enough abbreviations in your life this chapter, we're going to talk about a new abbreviation called CPCTC. So then we will have side, 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 side angle, side angle, side angle, 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 side, HL, and CPCTC. Yeah, you guys are going to love abbreviations. Now, before I really tell you what CPCTC stands for, let's talk about what we know so far about congruent triangles. So for two triangles, or really we said any polygon, to be called congruent, two things had to be true. Number one, three sets of corresponding sides had to be congruent, and all three sets of angles had to be congruent. Now this again only applies for our triangles that we're talking about three sets of sides and three sets of angles. But everything, all the angles had to match up to be correspondingly congruent, and all the sides would have to match up to be correspondingly congruent. But we said, you know what, we don't really need to know all 6 sets of information here. We could get by with half of it. And so we talked about our shortcuts. And so our 5 shortcuts, again, were side, 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 angle, side, angle, side, angle, 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 side, and our ASS in disguise, HL. Okay, so we said, again, we don't need to know all 6 pieces of information between two triangles. We can get by with half of it as long as the half that we have is a good half. And so these were the 5 good half pieces of 6 information that we could pull from. So when we would do an example like this, we would look at this and go, all right, we've got one set of congruent sides. We've got one set of congruent angles here. So far we have side angle or angle side. Is there anything else that's not marked between these two triangles that we could mark? And a lot of you are starting to pick up on and go, yeah, this side is reflexive with itself. So these two triangles are congruent because here's the shortcut, side angle side. And that's one of our good shortcuts that allows us to conclude that those two triangles must in fact be congruent with each other. Now that we know these two triangles are the same exact size, what else do we now know must also be true? Okay, so we already know this side is congruent to itself. We know these sides are congruent because it was apparently given to us. And we also know that these two angles, that they're already congruent because, again, they were given to us. So now we need to start thinking about all the things that aren't marked, that now we know should be marked because these two triangles are the same exact size. Okay? So the first thing I would think of would be, all right, well, if I've got 2 sets of sides that are marked congruent, and if these two triangles truly are congruent to each other, well, that must mean now that the third side of the top triangle, WK, is congruent to the third side of the bottom triangle, AC. This now must be true, since both triangles are the same size. I didn't know this before I concluded side angle side, but now that I have concluded side angle side, now I know this is true. Okay? So after the fact, I can mark that these two sides must be congruent. Now let's talk about what else is not marked that we can now mark as being true. So we need to move on to angles. So this angle, angle CAK, almost cake, must be congruent to angle WKA. That now must be true after we've said side angle side. And last but not least, we can conclude that angle W and angle C, they must in fact now be congruent with each other. Again, all this stuff I just wrote over here for 1, 2, and 3, we didn't know this was true at first. But now we know must be true after, again, that we've shown the triangles are congruent. All of that extra information, those 3 things that we just wrote down here, all that extra stuff after using one of our shortcuts is CPCTC. And CPCTC just stands for corresponding parts, that just means matching angles or matching sides, of congruent triangles, and that's why we say we can do CPC after using a shortcut. So we now know that we truly have congruent triangles by some side, 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 angle, side, angle, side, angle, 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 side, HL, that those corresponding parts are congruent. So when we came back here, we said, hey, these two triangles are congruent by side angle side. So these corresponding parts are now congruent. These corresponding parts are now congruent. And these corresponding parts are now congruent. That's CPCTC. Okay, so for every triangle problem we do, there's typically going to be 3 sets of CPCTC information. Because again, if you think about it, we have 3 sets of sides plus 3 sets of angles, but to use a shortcut, we only needed 3 things, right? A combination of sides or angles, or maybe all 3 sides. That leaves us with 3 unknown things. So I should say 3 known things and then 3 unknown things that we didn't use with the shortcut. The 3 unknown things after we use a shortcut is now our CPCTC information. So for number 2, it says determine which congruence, and by congruence they mean shortcut, if any, proves the 2 triangles are congruent. If they are congruent, write the congruency statement and any CPCTC information. If they are not congruent, determine what one additional thing would you need to know in order to show that they were congruent, and using which shortcut would you then be able to use. Okay, so if we're looking at these 2 triangles, I got one set of matching 90s, I got another set of matching angles. So right now I've got angle, angle, which isn't enough to say those 2 triangles are congruent. Is there anything else that I could mark that's not marked? And yes, we could use the reflexive side here. So now if I have an S involved, is this angle side angle or is this angle angle side? Well, notice the side is not in between the 2 arced angles, so this is really angle angle side. And some of you might go, well, what about the third set of angles? Couldn't we mark that they're congruent by theorem 4.1, and then could we use angle side angle? Absolutely you could, not a problem. Technically either one works fine. So number 1, are the 2 triangles congruent? Yes. Triangles congruent by, we found at first angle angle side. If you saw angle side angle first, then say that. Write the congruency statement. Okay, so the top triangle I'm going to call QRS. So if I call the first one QRS, notice this doesn't have anything here. There's no mark here. Then I have the 90, and then I have the 1 arc mark. So I need to repeat the same pattern down here. The S in this triangle had the no marking, and then the 90 was T, so it goes second. And then Q in this triangle had the 1 arc mark. So there's my congruency statement. And I have to write any CPCTC information. So right now, the stuff that I have marked that helped me get to angle side, anything else that's not marked is now CPCTC. So for example, side TS, this piece down here, now must be congruent to side QR. And again, if it's not necessarily obvious which piece matches up with which piece, here's TS or ST, which is the first 2 letters, and it better match up with the first 2 letters of the other triangle, which is QR. So this is CPCTC information. And if we were doing a proof, which we will very soon, we would say that this is true by CPCTC. So we know that's true now, after we've used angle side or angle side. We can now say the third set of sides, QT and RS, must be congruent. And it's CPCTC information. Now here's one of the rare cases of where technically the third CPCTC piece of information here, which would be these 2 angles, you can say that angle SQR is congruent to angle QST by CPCTC, or technically, as we've already mentioned, we could use theorem 4.1 to say that they're congruent as well. So you could technically give either one of these 2 things as the reason why you know they're congruent. Because technically we could use this information before we say the triangles are congruent. Okay? So you could say this before or after the shortcut, technically. Will that always be true? Not always. Okay, second half of this problem. Same thing, same type of question. Let's see if they're congruent. So I notice here I've got a 90, which means this other half must be 90, so that we add up to make a 180 for the straight angle postulate. So I got a set of matching angles, got an A. What else do we know? Oh, we got a reflexive side here, so we got an S. Okay. Any other sides, any other angles must be congruent here. Since they really didn't tell me anything, no. I really can't say that, these angles up here must be congruent, or these angles here must be congruent, or these sides here must be congruent, or these two bottom sides here must be congruent. No, I'm pretty much stuck at this point. So my answer would be no, not congruent. And so it says right here, if they are not congruent, determine what one additional thing you would need to know in order to show that they were congruent, and which congruence would you be using. So we need to be saying which shortcut. So let's see. Well, I notice if I said these two pieces were congruent, if that was true, then I'd have side angle side in both cases, and that's a good shortcut. So that could be one possible answer here. If AD is congruent to DC, then triangles congruent by side angle side. So there's one possibility. So let me erase these and see if we can find something else that would also work. So since I'm only limited to one additional thing, I can't just come out and say, oh, if everything else was congruent, obviously, then I could use any shortcut I wanted to. So if I've used side angle side, well, I'm 2/3 of the way to angle side angle, so let me try to figure out what other angle I would need to know. Well, I have angle side, well, it'd have to be these angles up here. So we could say if angle ABD, if this guy was congruent to angle CBD, which would be this guy over here, then triangles congruent by angle side angle. Okay, that works. What could be another answer we could use here? So out of side, 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 angle, 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 side, and HL. I've used side, angle, side. I've used angle, side, angle. With just one extra thing that I could say here, I wouldn't be able to accomplish side, 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 because I would need to say two sets of sides would be congruent to get side, side, side. Could I accomplish angle, angle, side? Yeah, I would need to know one more set of angles. And it's got to be the other set that I haven't talked about at all, which are angle A and C. So I could say if angle A was congruent to angle C, then triangles congruent by angle, angle, side. So that takes care of that. Could I use HL? Well, HL was nothing more than really ASS when the A was 90. So if I've got angle side and I need angle side side, I need an extra set of sides, but I got to make sure my angles are really 90 for even me to attempt this. And hey, my angles are 90. Sweet. So let's try to use HL. So in HL, I need hypotenuse and leg. What's already marked is technically a leg. So if the hypotenuses were marked congruent. So now if AB was congruent to BC, then triangles congruent by HL. So technically in this problem, there are 4 possible correct answers. And all you have to do is find one of them. So hopefully you found one of those 4, but just realize that there were 3 other potential answers you could have given. Now we're going to look to see what a proof looks like with CPCTC. And at first you're going to be going, let's be grumpy and complainy. It's really not going to be that bad. Trust me. So first, given information. Angle Q, congruent to angle R. Angle QPS, congruent to angle RSP. Let's mark that in our picture. Here's angle Q hiding over here. Angle R, so one arc mark apiece on them. QPS, which is this guy up here, I'm going to put 2 marks on. RSP, which is this person down here. So right now I've got angle, angle. Okay? And if you notice my proof statement, I don't want to prove that triangles are congruent. I want to prove that sides are congruent. This is a little different. Before we can prove that these sides are congruent, we first need to prove the triangles themselves are congruent. So what else is not marked between these two triangles that we could mark that would lead us to a shortcut? And I hear some of you guys, yeah, you guys are saying reflexive side. So let's say PS is congruent to PS. Since I used a congruent symbol, I would say reflexive PC instead of PE. And now I've got angle, angle, side in both triangles. So now I may conclude these two triangles are the same exact size. So I'll call the one on the bottom RSP must be congruent to triangle QPS because I identified angle, angle, side. And typically that's where we would stop if we wanted to prove the triangles were congruent. But now we're just going to take it one extra step, okay? If I want to show that SQ, which is this right side, is really congruent to the left side over here, PR, well, now that I know these two triangles truly are the same size, now I know that everything else about them that was not marked, I can now say is true. So now I literally have the proof statement here. I now know SQ and PR are congruent, and the reason is that CPCTC, that corresponding parts, and SQ and RP, those are corresponding parts, of congruent triangles, which I now know is true from that, are congruent, which is what I'm saying right there. Okay? And that's it for the proof. We're done. So most of the time, it's literally going to be one extra step after the congruent triangle statement. Not always, but most of the time. So let's end up with one more here. So given information, DG, congruent to GJ. So I'm going to put one congruent marking, one congruent marking. FG is congruent to GH, 2 markings, 2 markings. What else is not marked in this that I may? My vertical angles. So angle DGF is congruent to angle HGJ by the vertical angles theorem. And so now I notice I've got side angle side, which isn't my ultimate goal. My ultimate goal is to show that angles D and J must in fact be congruent. But I couldn't show that was true at this point. But now that I can say triangle DGF is congruent to triangle, now notice here it's not HGJ, it's got to be JGH. And you might go, why is it backwards? Well, if I start with D and go to G, notice I'm going through the 1 congruent marking here. And from G to F, I'm going through the 2 marking. If I go HGJ, I'm going through the 2 marking first, and then the 1 marking around the corner. I need to make sure that I hit the same pattern both times. So really, this triangle has been twisted or reflected around to what you would typically imagine it would be. So we have side angle side. Now that I know these two triangles truly are the same size, what else do I know is now congruent about them? This. Angle D is now congruent to angle J because of the CPCTC. And we're done. So that's all we're going to cover in this video. Tomorrow, or the next day in class, we will discuss examples 5 and 6 here. If you want to try them out on your own, get a little jump start, see if you can figure it out on your own. If not, we'll do them together in class. So that's all for video 4.